Welcome to Energy Central's Power Perspectives podcast, where we discuss the future of the energy and utility industry and the people making it possible. I'm Jason Price of West Monroe, and Energy Central's Community Engagement Ambassador. I'm based in New York City, and in Orlando, Florida is Matt Chester, Energy Central's Community Manager and producer of this podcast. Matt, today's discussion is top secret, so if anyone's out there listening to this podcast, we're going to have to kill you. Seriously, this topic is pushing the envelope on the application of artificial intelligence in grid modernization. Artificial intelligence is becoming more popular with the utilities. According to BIS research, AI in the energy industry expects to reach $8 billion by 2024. Most utilities I meet with at West Monroe have AI on their roadmap 2 to 3 years from now, followed by virtual reality by 2025 and neural networks by the end of the decade. So anyone listening with the background in neural networks, let's get you scheduled for an upcoming episode. Today, however, we will keep it simple and talk about artificial intelligence. In 2018, the Advanced Research Project Agency, ARPA, set out a long-term plan to get the utilities to accelerate the development of analytics, machine learning, and AI to improve all aspects of the grid. This multi-million-dollar initiative is called the National Infrastructure for Artificial Intelligence, or the ominous abbreviations of NI4AI. I'll repeat, NI4AI. So, to make sense of all this, we've invited Theo Laughner, one of the scientists behind ARPA-E's initiative. Backstage, I got to meet Theo, and all I can say to our listeners is buckle in, you're on for a wild ride. But before we dig in, let's thank our sponsors for making the Power Perspectives podcast possible. To West Monroe. West Monroe works with the nation's largest investor-owned utilities in their telecommunication, grid modernization, and digital and workforce transformations. From defending a rate case to preparing a business case, West Monroe utilizes a multidisciplinary team that blends utility, operations, and technology expertise, covering topics such as aging infrastructure, electric vehicles, AMI, MDM, and ADMS deployment, and industry disruptors like DERs and cybersecurity. To Esri, an international supplier of geographic information, GIS software, WebGIS, and geodatabase management applications. To Guidehouse, formerly Navigant Research, a premier market research and advisory firm covering the global energy transformation. And to Hancock Software, streamlined commercial and residential energy efficiency retrofits. Their customers deliver more than double the number of retrofit projects with the same energy engineering staff. Our guest today is Theo Laughner. Theo spent 22 years at the Tennessee Valley Authority overseeing power quality. Today he serves as CEO of PowerGRID-RX Inc. And Theo is going to share with us his experience working on NI4AI and help us understand the significance and application of AI on grid operations. Theo Laughner, welcome to the Power Perspectives podcast.
Thanks, Jason and Matt. Appreciate you having me here today. I'm really excited to talk with you guys.
Let's dig in with definitions. How about you level set for the audience? What is artificial intelligence? And generally speaking, why this matters for the utilities?
So let me start with a really boring, like Wikipedia type definition. AI is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. The example I love to use is my wife and I have this oven, and it's got artificial intelligence built in. Every time I slide a sheet of food in, it recognizes the food and then asks me how I want to prepare it. So let's say I have a sheet of bacon. I can put a sheet of bacon in, it'll go, this looks like bacon. Do you want it crispy or chewy? And then it runs the program accordingly. And then if at the end of the baking cycle, I decide it's not crispy or chewy enough, I can alter the program and then it will ask me how that alteration worked. All right. So I think it's amazing. If you think about it, I have an oven that recognizes food and then knows how to cook it. And not just bacon, though I love bacon. It also recognizes cookies. It also has, you can put some slices of salmon and asparagus in the oven together, and it has a cook cycle that recognizes that's what that it is, and then knows how to cook it just right. The other thing we like to do is a lot of dehydrating. So it has other programs and features, and it's internet connected so that new programs can be downloaded to it every month, and it recognizes more and more foods as time goes on. So you're thinking, okay, what does that have to do with the utility space? Well, think about it. Really, a better definition of AI, I think, as it applies to the utility space is, and I stole this from a friend of mine, Sean Murphy, who's the CEO at Ping Things. He defines it as AI as a cost-effective use of data at scale to use prediction to solve real-world problems. So let's unpack that a little bit. Think about computing technology and processing power. It's gotten a lot cheaper to the point where my wristwatch has artificial intelligence in it. My phone has artificial intelligence in it. My oven has artificial intelligence in it. So those real-world problems are things like we talked about, visual perception. So you mentioned in the introduction, things like augmented reality or virtual reality. Those are all extremely computing intensive things that have become very inexpensive because of AI. So how can I then apply that to the utility space? Well, the utilities have all of the sensor data out there that's just laying around dormant, not doing anything. It's not adding value. The purpose for which it was originally recorded has long since gone if it's an operations center. And so it's just sitting there not doing anything. Well, it could be repurposed to be training these newer artificial intelligence platforms. And what that would eventually lead us to are things like enabling us to move from a schedule-based maintenance program with our equipment to more of a predictive-based or even a condition-based maintenance program to our equipment. So that's sort of the thing. Taking all this data, turning that into analytics, having those analytics result in something that benefits the utility industry in the way of reducing cost or making the grid smarter.
Terrific. Theo, let's talk about your time at ARPA. How did you hook up with ARPA and the initiative?
Well, about 3 years ago, I was just finishing up a 21-year career at TVA, and one of the last projects I was involved in was building a capacitor bank health assessment tool with some power quality monitor data that we had deployed. From the time we figured out the problem, deployed sensors, developed an algorithm, deployed software, that whole process took about 3 years. And then on the heels of that was another 2 to 3 year effort to refine the process and improve it. So you think about how rapidly the grid is changing right now, and you think 3 years is an eternity. So Sean Murphy, the CEO of Ping Things, reached out to me and asked if I would like to help improve the state of the art with data analytics at utilities. And I was immediately in love with the idea, which was to create an ecosystem that speeds up the development of analytics for the utility industry. The promise of that is that we reduce the development time from 3 years to 3 weeks. And so that's how I got involved. It was a very exciting prospect, and it's been really a wild ride to be a part of.
That's great. So here's a throwback to our listeners. Like the show Get Smart, did you have to walk down a secret hall with doors that open up, down, and left and right? I want to know more about this experience. So tell us more about the project. What were the objectives? And who else was involved? And what role did you play?
Yeah, well, we have a secret handshake, and instead of emails, we use self-destructing messages. I'm just kidding. So firstly, ARPA-E funded that. ARPA-E is an offshoot of the Department of Energy that funds really innovative, transformative solutions for the industry. This particular project has a lead partnership with Ping Things and UC Berkeley to help kind of perform the work. And it really has 3 pillars. One was to build a platform. A lot of the challenges that we'd identified with doing data analytics in the past is sort of this constant chicken and egg scenario. We need data to train analytics, but we don't have data to train analytics, but we don't have the data because we don't have a place to put the data to train the analytics. So in that regard, building a platform made a lot of sense. Have some place to store data. That platform necessarily needs to have the ability to work with large volumes of data. It needs to be secure. It has all sorts of requirements. But at the end of the day, build the platform. Part 2 of the system is to fill that platform with data and then make that data available and hosted within the platform to our 3rd pillar, which is the community. We want to build community by recruiting a community of analysts and practitioners to help the industry identify and develop new use cases for AI on the grid.
Theo, you recently published an article on Energy Central with your colleagues from the Berkeley National Lab. In your article, you say the goal of the project is to support the development of new analytical tools that can drive the industry forward. Can you give us some examples, and what are some of the opportunities you see AI of value to the utilities?
Well, traditional utility systems are based on very stochastic or analytical methods of you have a very fixed model, you supply that model with data, and out comes an answer. If you think about a lot of systems like Twitter or Facebook, they're much more random. There's a lot more chaos and entropy in those systems because people are sort of unpredictable, especially in large numbers. So if you think about the corollary here is the grid used to be a very organized system. You had generation was connected to transmission was connected to distribution was connected to customers. The power all flowed in a single direction, from generation to the customer. In the new grid, where we have renewables at the edge, we have battery storage systems at sub-transmission or distribution, we have large-scale renewables, sometimes at medium voltage distribution or even transmission. It's no longer this nice unidirectional power flow. It's sort of this chaotic spider web of power flows and so forth. And so this chaos and entropy has really challenged the status quo models that we've used for many decades now. There's a second aspect of this. So, you've got the grid change, which is a real issue. The second issue is that I think back to my times when I was at TVA, I was responsible for managing one of the largest power quality monitoring systems in the world. It was a constant source of frustration to be able to identify an issue in data, and then the need to manually mine or comb through 1,600 meters to see how widespread whatever the issue we identified was. And sometimes it wasn't widespread at all, but you still had to go through all 1,600 meters. So traditional monitoring solutions and software systems that we have just are too manual of a process in order for us to really do this in an expedient sort of way. Next, there's still a certain amount of guesswork. Even once you find the problem, what caused it, what's the scope, how do I identify the problem in a programmatic way? And that is a challenge. I'll reference back to my capacitor health problem. Okay, I've got an algorithm. How do I get it in a system where my data is without a 3-year development cycle? And then the other thing is, once I develop that algorithm, could I apply it to real-time systems, for example, such that I could almost predict when capacitor banks were starting to go bad, as opposed to just waiting until things were bad enough that they were causing customer problems.
Since we're talking about an initiative sponsored by ARPA, there must be a sharing component to this. And this brings to mind the Green Button initiative that's running across self-selected utilities on a voluntary basis. So I'm not sure how successful or impactful Green Button has done, but can you compare and contrast this initiative to the Green Button initiative?
Well, I think the Green Button initiative is really neat. It was primarily designed, as I understand it, for customers to share their usage data anonymously. So how much water did I use? How much electricity did I use? How much gas did I use, for example? So it's got a very customer-focused component, though it is partnered with utilities. Really, the NI for AI is designed to share different kinds of data. If you think about usage data, it typically comes in anywhere from 1 to 30 minute sort of value. So every 1 minute or 15 minutes or 5 minutes or 30 minutes, whatever. If you think about sensor data in the utility space, you have things like relays, which are point-on-wave data for a very short period of time. You have synchrophasers, which are relatively low resolution data, but happening all of the time. You have things like power quality meters, which are extremely high fidelity when they're in event capture mode and at a lower fidelity when they're in steady state mode. So you have all these different sensor types that are on the grid and data points that you can collect. And there's even emerging sensors, for example, that are capturing 1,000 samples per cycle continuously. And so the platform was really designed to be able to handle data from any of those devices that are typically found on the grid at any velocity of data or volume of data that you can supply to it, even up to terabytes or petabytes of worth of data, so that it could be used efficiently with analysis to work on all data as part of everyday workflows. Similar products out there for collecting large volumes of data exist, but often they're designed sort of as a catcher's mitt. They're really good for shoving data into, but getting data back out of can be very slow. This system was designed with getting the data back out at its core. The other thing that differentiates us, I think, from Green Button is that our audience is slightly different. We want to create a community around this data, a vibrant community that involves all of the stakeholders of the industry, from students to researchers to vendors to utilities to whoever wants to participate in the ecosystem. And so I think that really differentiates us as, one, the types of data available, and again, two, the speed, performance, and the fact that we're not just building a tool, we're trying to build an entire ecosystem around this platform.
It sounds like these data sets could be really valuable to decision makers. What has prevented the industry from developing solutions to capitalize on data sets like this in the past?
Well, there's been a lot of reticence from utilities to share the data, for one. As you can imagine, data privacy concerns, a lot of the data that we're looking to capture could have operational significance. And so one of the things that we've tried to do with this is make it anonymous. The data, as it's posted into the system, is anonymized so that the source utility is not known. We have really worked to ensure that our security is good so that we don't have to worry about third parties, people who aren't supposed to have access to the system getting in. I think there's also been sort of a thought process that a lot of the big data companies have made, and I know the utilities will identify with this, utilities have made the process of moving electricity around the grid look so easy that people want to try it themselves. And the devil is in the details. I think the same thing is true. The big data companies that specialize in these AI systems make it look really easy. And so in some cases, utilities have decided, you know what, we're going to stand up our own data science center and our own experts and all of that. So some utilities have tried to capitalize on this. But one of the technical barriers is that the amount of data that's needed to train these tools is huge. So I'll go back to my oven issue. I like bacon. I have it pretty frequently, but it takes thousands, millions of pans of bacon in order to accurately train an AI to recognize a sheet of bacon. A utility by itself will probably not generate the volume of data that's needed by itself quickly enough to actually train an AI system. So one of the key things is that by everybody pouring data into this tool is that we can develop these AIs and train these AIs and analytic processes so much faster than even a utility who decides to do it by itself could, just because the quantity of and availability of so many more experts, so many more data sources, and all of that. So we needed the platform to really be there. I think part of it is utilities are experts at utility systems, not IT systems, and certainly not complicated systems like what we have in AI type systems. And so, again, that's a challenge. And part of it is skills. If you look at the number of folks who have really a great deal of technical proficiency in this area, it's still a pretty small pool of people. So it's not a skill that we teach engineers in school right now. Maybe a handful of computer science programs across the industry do. And part of the benefit of this platform like this is that it enables people to begin developing these skills for themselves at their own pace. And so it kind of enables people to become proficient and expert at this, which we desperately need to start cultivating those sorts of skills within our industry.
Theo, I'm wondering, given the need to get that data from many different utilities to kind of get that at scale data set that you mentioned, are there any issues you run into in terms of data quality from different utilities that are maybe handling that data in different ways before contributing it?
Oh, I think that's a great question. And the fact is that that is a huge concern. In projects that I have been involved with in the past where we've tried to get many utilities to share, what we've recognized is that there's a real need to understand some of the metadata associated with that. That is data about the data. So it's not really fair, for example, to compare a transmission voltage to a distribution voltage. They have different exposures, they have different voltage levels, they have different design parameters. So I do think that there is some sort of attribution that we need to collect in order to make sure that as we're training the algorithms, that we're training them for the right thing. Some of that metadata comes along naturally. So for example, if you have a very high resolution data source like a DFR or a point-on-wave device versus a relatively low resolution thing like a revenue meter, you want to make sure that you're using the right algorithms for the right type of data. And so some of that comes automatically because this has got 1,000 samples a cycle and this has got 2 samples per cycle, for example. So I think there is definitely a need to make sure that we've got proper attribution around the data.
You've stressed upon the fact that the data be open and accessible. Is this coming from you, or is this foundational to NI for AI initiative? And why is it so important that the data be openly accessible?
So right now, data is only available to people who work in the industry. So for example, if I'm working at a utility, I may have access to my utility's data. But there are other audiences for it. As I mentioned earlier, researchers, vendors, students that bring different skills to the table. And so giving them data will allow more people to contribute in more meaningful ways. So is this just my view? No, this is actually part of the NI for AI initiative. So what we're doing is, not only are we making the platform available, but a part of our project is actually to deploy sensors on the grid that is fully anonymous and make that data available. So we're actually deploying our own sensors as part of this. That is a real departure from what's currently done. But by doing this, it means that analysts can work on solutions that the utilities need. Those solutions require rich data sets to train the algorithm, so we can provide that data set. We need to put data in the hands of people with skills. So these are software AI developers and software folks, people who are well-trained in this space. But we need to couple that with utility and engineering folks who understand the physics behind what's going on in the data. And then from that, we also have the platform has the ability not only to capture data from utilities, and so that would be an excellent way for folks to get involved, but also synthetic data. So that's data from models. So that there's this rich ecosystem of data that's available, both real, synthetic, and in situ data. So we can take data from monitors that are already installed. And we would definitely want that. So one way it would be great for listeners to get involved would be to reach out to us and get their data over to us.
Great. Given that we are only on the cusp of AI and how it's used in the energy sector, in your experience working in this space, what advice do you have for our listeners about how they can set themselves up to be successful in an industry that is changing so quickly? And what can they do to get ahead of the game and become part of the energy transformation?
Well, I'll tell you, I think there's a couple of things that they can do to get started to become using your Get Smart, maybe a not so secret agent for change. And that is, they can check out our website. So ni4ai.org is a place where you can get all sorts of information. We have a blog there. We have data there. You can sign up for an account. It's free, and you have access to the data that's available on the platform today. We also have a calendar of events there, which outline opportunities for training and all sorts of other things. And of course, if you want to talk to somebody directly, you can reach out to the email address info@ni4ai.org.
Fantastic, Theo. We're thrilled to have you on our show and cover this rather complicated yet thought-provoking conversation and simplifying it for us lay people who are listening in. I'm sure we'll be hearing more about this in months and years to come. So we thank you for sharing your insight with us on today's episode and podcast.
Oh, man, thanks for having me. It's been great talking to you guys about this, and love to hear more from your listeners.
Beautiful. You can always reach Theo through the Energy Central platform, where we welcome your questions and comments. Once again, I'm your host, Jason Price of West Monroe. Plug in and stay fully charged in the discussion by hopping into the community at energycentral.com. See you next time at the Energy Central Power Perspectives Podcast.